Hello students, welcome to experiencetutor.com. Today's lesson is class 12 chemistry solid state part 2.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Now we'll study about crystalline and amorphous solids. Solid substances are available in crystalline and amorphous forms. There is difference in their structure and formation. Crystalline solid substances are rigid and incompressible. They have definite shape. Their geometrical structures are systematic and definite. The reason for this is the regular and definite arrangement of molecules or ions in three-dimensional shapes. They have got definite and sharp melting points. The example of this type of crystalline solids are sodium chloride, potassium chloride, etc. Amorphous substances, on the other hand, are also rigid and incompressible, but they have no definite geometrical shapes. The periodicity of the definite formation or geometry of amorphous substance is not observed. Even when the atom or ions are bound very tightly. Their melting points are not sharp. They possess some range of temperatures. The example of such amorphous substances are glass, rubber, etc. In the table, we will give more explanation and differences between crystalline and amorphous solid substances. First column will tell the property, second column is crystalline solids, how they seems to be with the given property, and third column is amorphous solid, how they deal with the given property. First, shape. Crystalline solids have definite shape and possessing characteristic geometry. Amorphous solid, on the other hand, have irregular shape. Second, melting points. Crystalline solids have definite and sharp melting point. which is the characteristics of the crystal of solid. On the other hand, amorphous solid becomes soft gradually during the small temperature range, that is, have no definite sharp melting point. Third, fusion enthalpy. Crystalline solids definite and characteristics fusion enthalpy. Amorphous solids have non-definite and characteristic fusion enthalpy. Fourth, cleavage property. Crystalline solids divided into two parts by cutting the crystal with sharp tool-like knife. The surface of the new part obtained in the plane and shaft, that is, it is as original one. On the other hand, amorphous solid divided into two parts cutting crystal with say sharp tool-like knife, but the surface of new part obtained is not as the original one. It is irregular. Fifth, nature. Crystalline solids are true solids. On the other hand, amorphous solids are pseudo-solids or supercooled liquids. Sixth, order of arrangement or constituent particles. Crystalline solids, the order is maintained till a long range. In amorphous solid, the order is maintained in a short range. Property 7. Effect of temperature. Crystalline solids. For crystalline solids, the graph of temperature and time obtained on cooling after heating is not a curvature. The temperature remains definite during crystallization. On the other hand, amorphous solids, the graph between temperature and time obtained on cooling after heating is a curvature. Temperature range is obtained during crystallization. Eighth property. The property like electrical conductivity, thermal conductivity, mechanical strength and refractive index are different in different direction for crystalline solids. Their property like electricity conductivity, thermal conductivity, mechanical strength and refractive index are same in all directions. Now we'll study about unit cell. What is unit cell? Smallest portion possessing the chief characteristic of crystalline solid is called unit cell. Such unit cells are arranged with each other in three-dimensional direction to form crystal. This type of arrangement is called crystal lattice. In the figure, it is shown how crystal lattice looks like. Characteristics of crystal lattice. First, each point of lattice is called lattice point or lattice position. Second, each point in the crystal lattice represents one constituent particle, which can be an atom, a molecule, or an ion. Third, the lattice points are connected by straight lines so that the geometry of the lattice can be indicated. Characteristics of unit cell. First, its dimensions are on its three edges A, B and C. These edges may be perpendicular to one another or may not be perpendicular. Second, unit cell becomes characteristics by parameter ABC and angle alpha beta gamma, where ABC are edges and alpha beta gamma are angles between the edges. These are clearly shown in the figure. In the figure we can see the edges A, B and C and the angle between the edges alpha, beta and gamma. Primitive and centered unit cells. Before doing this, we should know what are these primitive and centered unit cell. The unit cells can be divided into two parts, primitive unit cells and centered unit cell. Let us go details about this. Primitive unit cell. When constituent particles are arranged on the 4 points of the 4 corners of the unit cell, it is called primitive unit cell. B. Centered unit cell. When one or more constituent particles are arranged at other places or sites in addition to the site of the corners, it is called centered unit cell. Centered unit cell can be of three types. First, face-centered unit cell. Second, body-centered unit cell. Third, end-center unit cell. Face-centered unit cell. In this type of unit cell, one particle is arranged in the center of each face or side in addition to the particles arranged on each corner of the unit cell. Body-centered unit cell. In this type of unit cell, one particle is arranged on the center of the body in addition to each particle arranged on the 4 corners of the unit cell. End-centered unit cell. In such unit cell, one constituent particle is present at the center of any two opposite faces, beside the one present in its corner or at its corner. Let us study more detail with example about this. In this table, first column is the serial number, second column is crystal system, third column is possible variation, fourth column is axial distance or distance of edge, fifth column axial angle, sixth column example. So first, cube. The possible variations may be primitive, body-centered, face-centered. Axial direction or direction of edges will be A is equal to B is equal to C. Axial angle alpha is equal to beta is equal to gamma is equal to 90 degree. Example, NaCl, ZnS, zinc blende and Cu. Second, tetragonal crystal system. Possible variation, primitive, body centered. Fourth column, axial direction or distance of the edges. A is equal to B not equal to C. Angle, axial angle, alpha is equal to beta is equal to gamma is equal to 90 degree. Example, white tin SnO2 TiO2 Sa CaSO4. Third, orthorhombic. Possible variation, primitive, body centered, face centered, end centered. Axial distance, A is not equal to B, B is not equal to C. Angle, axial angle, alpha is equal to beta is equal to gamma is equal to 90 degree. Example, rhombic sulfur, KNO3, BaSO4. Fourth, hexagonal. Primitive, possible variation, maybe primitive, is primitive. Axial distance or distance of H, A is equal to B, not equal to C. Axial angle, alpha is equal to beta is equal to 90 degree. Gamma is equal to 120 degree. Fifth is crystal system is rhombohedral or trigonal. Possible variations may be primitive, axial distance, A is equal to B is equal to C, angle is alpha is equal to beta is equal to gamma is equal to is not equal to 90 degree but less than 120 degree. Monoclinic, possible variation, primitive and centered. Axial distance, A is not equal to B is not equal to C. Axial angle, alpha is equal to gamma is equal to 90 degree. Beta is not equal to 90 degree. Example, calcite or CaCO3, cinnabar HGS. Monoclinic, possible variation, primitive and centered. Axial distance, A is not equal to B is not equal to C. Alpha is equal to gamma is equal to beta is equal to 90 degree. Beta is not equal to 90 degree. Example, monoclinic sulfur Na2SO4 dot 10H2O. Triclinic, possible variation, primitive, axial distance, A is not equal to B is not equal to C. Axial angle, alpha is not equal to beta is not equal to gamma is not equal to 90 degree. Example, K2Cr2O7 CuSO4 dot 5H2O dot H3PO3.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.